Now we're going to look at using the binomial expansion to estimate binomial estimation. Part A, find the first 4 terms in ascending powers of x of the binomial expansion of 1 minus x to the power of 8. So n is 8. We want NC0, NC1, NC2, NC3. So we'll use the calculator to generate that line of Pascal's triangle. So 8, choose 0 is going to be 1. Then we're going to have 8. So it's 1, 8, 28, 56. So 1, 8, 28, 56. The first one is going to be 1 times 1 to the power of 8. Then we've got 8 times 1 to the power of 7 times negative x to the power of 1 plus 28 times 1 to the power of 6 times negative x squared, and then 56 times 1 to the power of 5 times negative x cubed. So just simplifying this, we'll get 1 minus 8x plus 28x squared minus 56x cubed. So that's our answer to part A. For part B, by substituting an appropriate value of x, find an approximate value for 0.99 to the power of 8. So what do I have to change x into to make these equal? So how can I make 0.99 to the power of 8 the same as 1 minus x to the power of 8? So I can just get rid of the powers of 8 from both sides. 1 minus x equals 0.99. So x is going to have to be 0.01, because 1 minus 0.01 is 0.99. So if x is 0.01, I'm just going to substitute that in for x. That will be 1 minus 8 times 0.01 plus 28 times 0.01 squared minus 56 times 0.01 cubed. And I'll just use the calculator. So 1 minus 8 times 0.01 plus 28 times 0.01 squared minus 56 times 0.01 cubed. And we have 0.922744. (0.9227744), and if we want to, we can check. So 0.99 to the power of 8 should be something very similar to this. So 0.922744, and then there's a 6944 on the end. One for you to try, so pause the video and give it a go. Find the first 4 terms in ascending powers of x of the binomial expansion of 1 plus 2x to the power of 10. So let's generate the right line of Pascal's triangle. So we're going to have 1, 10, 45, 120. 1, 10, 45, 120. So the first term, 1 times 1 to the power of 10. Then we've got 10 times 1 to the power of 9 times 2x to the power of 1. 45 times 1 to the power of 8 times 2x squared. And 120 times 1 to the power of 7 times 2x cubed. That's going to be 1. And then plus 20x plus 180x squared. What's 120 times 8? 960 plus 960x cubed. By substituting in an appropriate value of x, find an approximate value for 1.02 to the power of 10. So how can 2 plus x equal 1.02? Take away 1 from both sides, half both sides. X is going to have to be 0.01. So it's 1 plus 20 0.01s plus 180 times 0.01 squared plus 960 times 0.01 cubed. 1 plus 20 times 0.01 plus 180 times 0.01 squared plus 960 times 0.01 cubed. 1.21896. And again, I'll just give this a quick check. So put in 1.02 to the power of 10, and we've got 1.21899, and then it's slightly different at the end. It's not going to be exactly the same. It's an approximation. Another one, find the first 4 terms in ascending powers of x of the binomial expansion of 3 plus x over 5 to the power of 6. So we want 6, choose 0, which is 1, 6, choose 1, which is 6, and then 15, so 1, 6, 15, 20. 1, 6, 15, 20. So our first term, 1 times 3 to the power of 6. Then we're going to have 6 times 3 to the power of 5 times 5 over x to the power of 1 plus 15 times 3 to the power of 4 times 5 over x squared plus 20 times 3 cubed times x over 5 cubed. Let's use the calculator. So we've got 3 to the power of 6, which is 729. Then we've got 6 times 3 to the power of 5 times 1 over 5, sorry, 1 over 5x to the power of 1. So that's 1,458 over 5. X. Then we have our 1 over x squared, our 3 to the power of 4, and our coefficient 15. 243 over 5. That's our x squared. And then we have cubed. Cubes, the powers always add up to 6, and the coefficient 20. 108 over 25. X cubed. So that's our expansion. By substituting in an appropriate value of x, find an approximate value for 3.05 to the power of 6. So what do we have to make x? 3 plus x over 5 is equal to 3.05. That means x over 5 is 0.05. X must be 5 lots of 0.05, which is 0.25. So this time we have to make x 0.25. So we're just going to substitute it in wherever we have x, change it to 0.25. And just type it into the calculator. So 729 plus 1,458 over 5 times 0.25 plus 243 over 5 times 0.25 squared plus 108 over 25 times 0.25 cubed. And that's 805.005. And 3.05 to the power of 6 is 805.005 8494. One for you to try. Give it a go. Find the first 4 terms in ascending powers of x of the binomial expansion of 2 plus x over 4 to the power of 6. So again, line 6, 1, 6, 15, 20. We've got 1 times 2 to the power of 6 plus 6 times 2 to the power of 5 times x over 4 to the power of 1 plus 15 times 2 to the power of 4 times x over 4 squared plus 20 plus 20 times 2 cubed times x over 4 cubed. So let's just simplify this. 2 to the power of 6 is 64. Six times 2 to the power of 5 times 1/4 is 48. So 48x. We're going to have a quarter squared. 2 to the power of 4, a coefficient of 15. For the next term, that's 15. So 15x squared. And then we're going to have cubed, and 20. Which is 5 over 2. So 5 over 2 x cubed. By substituting an appropriate value of x, find an approximate value for 2.025 to the power of 6. So if 2.025 is equal to 2 plus x over 4, 0.025 must be x over 4, taking away 2 from both sides. And then times both sides by 4. So 4 times 0.025 is 1/10, 0.1. So we're substituting in 0.1. So we're going to have 64 plus 48 0.1s plus 15 times 0.1 squared plus 5 over 2 times 0.1 cubed. 64 plus 48 0.1s plus 15 0.1s squared plus 5 over 2 0.1 cubed. So we have 68.9525. and it was 2.025 to the power of 6 that we were approximating. So 68.9525 2355.